Good morning, Year 9. This is Miss Teresa. Today, we're going to talk about energy. Our lesson objective for today is to explain the meaning of energy. Success criteria: I can use the expressions kinetic energy is equal to half mv squared and gravitational potential energy is equal to mgh. Before we move on, we'll have a quick review about work because it's also related to energy. When a force moves an object, it does work and energy is transferred to the object. The man pushing the box is doing work. If he uses 600 joules of work to do this, then he loses 600 joules of energy. The box being pushed gains 600 joules of energy, but not the full 600 joules, as some is lost as sound and heat. Therefore, the energy is transferred from the man to the box, and work is done as he pushes it to a certain distance. The amount of energy transferred is equal to the work done. What is energy? In physics, energy is a property that must be transferred to an object in order to perform work on the object. Scientists also define energy as the ability to do work. The law of conservation of energy states that energy can be converted in form but not created nor destroyed. The SI unit of energy is the joule, which is the energy transferred to an object by the work of moving it a distance of 1 meter against a force of 1 newton. Hence, 1 joule is equal to 1 newton meter. There are many different types of energy. Here are some of them. Kinetic energy is the energy in a moving object, example, a moving car. Gravitational potential energy is the energy due to the height of an object, example, a skier on a slope. Elastic potential energy, energy in a stretched or compressed object, example, a spring. Chemical energy, energy contained in food or fuel, example, food and petrol. Electrical energy, energy in the flow of electrons, example, a battery. Nuclear energy, energy released when the nucleus of an atom splits. Light, energy given out by any hot object, example, the sun or light bulb. Sound, energy given out by vibrating objects, example, a loudspeaker. And heat, energy contained in any hot or warm object, example, burning coal. We also have what we call mechanical energy. Mechanical energy is the energy in an object due to its motion or position, or both. We can say that mechanical energy is the sum of kinetic energy and gravitational potential energy. We will understand this diagram better after discussing kinetic energy and gravitational potential energy. Kinetic energy. Kinetic energy is the energy which an object possesses by being in motion. The kinetic energy of an object depends on its mass and speed. The higher the mass of an object, the higher is its kinetic energy. The faster it moves, the kinetic energy also goes higher. Kinetic energy of a moving object can be calculated using the equation Ke is equal to half times mass times speed squared, or in symbols, Ke is equal to half mv squared, where Ke is the kinetic energy in joules, m is mass in kilograms, and v is the speed in meter per second. Gravitational potential energy. Gravitational potential energy is the energy an object possesses due to its position above the ground. The amount of gravitational potential energy an object has on Earth depends on its mass and height above the ground. The more massive an object is and the higher it is positioned with respect to the ground, the higher is its gravitational potential energy. The gravitational potential energy of an object raised above the Earth's surface can be calculated using the equation gravitational potential energy is equal to mass times gravitational field strength times vertical height raised, or in symbols, GPE is equal to mgh, where GPE is the gravitational potential energy in joules, m is the mass in kilograms, g is the gravitational field strength in newtons per kilogram, and h is the change in height in meters. Now let's go back to the concept of mechanical energy, where we said that mechanical energy is equal to the sum of kinetic energy and gravitational potential energy. This is Jason. He wants to be a Guinness World Book record holder by jumping from the top of Burj Khalifa. Let's analyze 3 important points of his jump. At the top, his GPE, gravitational potential energy, is at maximum. Why is it at maximum? Because he is at the highest point of his jump, but his kinetic energy is equal to 0 because he's still not moving at this point. At this case, mechanical energy is equal to GPE plus 0. At any point between the highest and the lowest point of his jump, his GPE will be lost. Why is it lost? Because he has lost height from the top also to any point of his jump. But any GPE lost in this case is equal to kinetic energy gained. He is losing height, but he is gaining speed as he falls. At the lowest point of his jump, that is on the ground, he lost all his GPE. So GPE, gravitational potential energy, here is equal to 0. But KE, kinetic energy, is now at its maximum. ME at this point is equal to kinetic energy plus 0. Since ME, mechanical energy, is equal to the sum of KE, kinetic energy, and GPE, gravitational potential energy, at any point of his jump, and at the highest point his KE is equal to 0, and at the lowest point his GPE is equal to 0. We can also say that GPE at the top is equal to the KE at the bottom of his jump. This is according to the law of conservation of energy. Now, based on these equations that we have just discussed, we are going to solve a problem. A moldy tomato of mass 140 grams is dropped from a height of 1.7 meters. Calculate its speed as it hits the floor. We already know our basic formulas. We have KE is equal to half mv squared, and PE, gravitational potential energy, is equal to mgh. Now we are going to use both of these equations in solving this problem, since we know that KE gained is equal to GPE lost, or vice versa. Furthermore, we have to convert 140 grams to kilograms, because kilograms is the SI unit of mass. Therefore, we have to divide it by 1000, so we will get 0.14 kilograms. The height is already in meters, therefore no need to convert for that. Now we're going to solve for GPE lost. GPE lost is equal to m into g into h. Mass is 0.14 kilograms times the gravitational field strength, which is 10 Newton per kilogram, and the height is 1.7 meters. Now we are going to get a value of 2.38 joules in this case. So we have to take note of that. The GPE loss is 2.38 joules. We're just going to write it here. GPE lost is equal to 2.38 joules. Now we know that GPE lost is equal to KE gained. Formula for kinetic energy is equal to 1/2 times the mass times the v squared, and that is equal to GPE lost. Okay, substituting 2.38, we are going to get 2.38 is equal to 1/2 of the mass. Mass is still 0.14 times v squared. Now we are going to manipulate this. 2 times 2.38 will be 4.76 is equal to 0.14 v squared. Dividing both sides by 0.14, we'll be able to cancel this. Therefore, v squared is equal to 4.76 divided by 0.14 is equal to 34. Now, to remove the square, we're going to get the root of both sides. Therefore, v is equal to 5.83 meter per second, which is the final answer because that is the speed as it hits the floor. Now you already know that the next problems will be your work. So there are 3 problems for you. You're going to calculate them according to the example that I've given you. So what have we learned today? We learned to use the expressions kinetic energy is equal to half mv squared and gravitational potential energy is equal to mgh. I hope you enjoyed our lesson. This is Mr. Essa signing off. Have a nice day.